Writing a quadratic function in the form y equals ax minus p squared plus q is a very user-friendly way of writing the quadratic function. A little bit like writing the line in the form y equals mx plus b. You can tell a lot about the quadratic just by looking at the equation when it's in that form. In particular, you can tell exactly where the vertex is. So the vertex is at pq, and you can tell whether it's facing up or down by whether the sign of a, that leading coefficient, is positive or negative. And a also gives you the vertical expansion factor. So when a is large, or the absolute value of a is large, it'll look really stretched out or skinny. And if a is absolute value of a is close to 0, like a half or a third, it'll be much wider, much compressed, more compressed vertically. So let's take a look at some examples. If you're given a graph and you can identify the vertex and one other point, just one other point, then you can find the equation of the quadratic function. So here's an example. Let's say we're given a quadratic. It's facing up. Right off the bat, you know that the value of a is going to be positive. If the vertex is at 2, 3, and you can identify one other point, let's say the point 419. How do you start? Well, you start with the vertex. So the x-coordinate is p, the y-coordinate is q. So right away you can write y equals a, x minus 2 squared plus 3. All you're doing is substituting the x and the y-coordinate of the vertex for p and q. To find a, you need that one other point, and remember, every point on a parabola is the solution to a quadratic equation. The infinite number of points in the parabola represent the infinite number of solutions to the equation. So if it passes through the point 419, that means it's a solution of this equation. So we can replace the y with 19 and the x with 4, and we should get a true statement. And of course that leaves us with an equation, an a, to figure out how to make that statement true. We can subtract 3 from both sides. 4 minus 2 is 2, and 2 squared is 4, so we have 4a on the right hand side after subtracting 3. And then we can divide both sides by 4 to get a value of a of 4. So it's positive, exactly as we expected, and we can now write the full equation of this parabola, this quadratic function. It is 4x minus 2 squared plus 3. Now let me point out one thing that will help you sketch parabolas very quickly given a quadratic function, and it'll also serve as a double check for you when you're doing this sort of task. That a value should tell you the change in the y-coordinate when you move one unit either side of the vertex. So since the a value here is 4, that means we should be able to go 1 unit either side of the vertex with a change in the y value of 4. So this should be here 3, 7, and 1, 7. So if it isn't on your graph, then you've made a mistake. You've done one of the calculations wrong. And if you're sketching it, obviously it gives you a nice way to get the width of the parabola or the height of the parabola, because you're taking into account that leading coefficient, which is the vertical expansion. So let's try another one of these just to get the hang of it. This time we'll have a parabola facing down. So we know right off the bat the a value is going to be negative, and if the vertex is given as -3, -5, and we've got one other point, let's say -6, -8, we can start exactly the same way. We've got the vertex, so we can start writing the equation of the parabola. Y equals a, x minus -3. Now when you subtract a negative, it's like adding, so instead of writing x minus -3, let's just write that as x plus 3 squared minus 5. we take the point negative 6, 8, plug it into this equation, and solve for a. So negative 8 is equal to a. Negative 6 plus 3 squared minus 5. We'll add 5 to both sides. And negative 6 plus 3 is negative 3. Square it, you get 9. So we have 9a on the right-hand side. We'll divide both sides by 9, and you get negative 3 over 9, which reduces to negative 1/3 on the left. So we have our equation. We can write the full equation now. Y equals negative 1/3. That leading coefficient is negative as we expected because this is facing down. X plus 3 squared minus 5. And again, if you want to look for a double check, just verify that if you go 1 unit either side of the vertex, your y coordinate goes down by 1/3. So that means we should have points either side of the vertex, negative 2 and negative 4, with y coordinates that are just 1/3 of a unit below the vertex. So we can just write that as minus 5 and 1/3. It's not going to be that easy to perfectly identify that if you're looking at a graph, but it should be easy to see if it's in the right ballpark. Now, what if you don't quite have all the vertex? What if you're only given one of the coordinates? That can happen if you're told something like the axis of symmetry. So if you're given the axis of symmetry, let's say that it's x equal to 1. You're going to need more than just one additional point. So if it's a graph, hopefully you can identify a couple of points, but if you're just given a sketch and told a couple of points, then you're going to need 2. So let's say we're given these 2 points, 2, 5, and negative 3, 2. Well, what can we do? We know the vertex, the axis of symmetry passes through the vertex, and so if we're told the axis of symmetry is x equal to 1, we know the x coordinate of the vertex is 1. We just don't know what the y coordinate is. And remember, we usually symbolize the vertex with PQ, so we can call this 1Q. Well, we can start writing the equation of the parabola just like we did before, except we can only fill in one of the two, p and q. So we've got x minus 1 squared plus q. Alright, so let's take both of those points, plug them in one at a time. We'll plug in point A first. 5 is equal to a times 2 minus 1 squared plus q. Now if I simplify that equation, I get 5 is equal to just simply a plus q. Now if I plug in the second point, let's do that. Y equals a x minus negative 3. Oops, sorry. Negative, didn't think something looked right there. Negative 3 minus 1 squared plus q. Alright, let's simplify. Let's back up again and plug in the y coordinate 2. Alright, that looks better. 2 equals a times negative 3 minus 1 squared plus q. Let's simplify that. The negative 3 minus 1 is negative 4. Square that and you get 16. 16a plus q. So, what are we going to do with this? We have two equations with two variables, and hopefully you remember something about systems of equations, because we can solve this. These are two linear equations. We can think of this as equation 1 and this as equation 2. So the goal of systems of equations is to eliminate one variable to get an equation in the other. And the easiest variable to get rid of here is q. We can take equation 2 and subtract equation 1. The left-hand side becomes 2 minus 5, which is negative 3. the right-hand side becomes 15a, and of course the q's disappear. So we've now got a very simple equation in a. We can solve that, divide both sides by 15. Negative 3 over 15 reduces to negative 1/5. So we've figured out a, and we'd like to be able to know what q is too, so we can use equation 1 there. If I plug this into equation 1, I get 5 is equal to negative 1/5 plus q, and that's an easy equation to solve for q. I can just simply add 1/5 to both sides. I can either write q as 5 1/5, or I can change the 5 to 25 over 5, and then add 1/5, and write q as 26 over 5. Doesn't really matter if I write q as a common fraction or a mixed fraction, but now I have everything. I've got my p, which was easy. I've got the q, and I have a. So I can write the equation of this parabola, y equals negative 1/5 x minus 1 squared plus 26 over 5. So it's facing down. That leading coefficient is negative, and you can pull out a piece of graph paper if you like, and you can sketch this just to make sure it makes sense, that it should actually be facing down.